Hi everyone, welcome back. Today we're going to talk about Chapter 2 and the introduction to that, which will involve our first model. Our first model is called the Production Possibilities Frontier, or the PPF. Right? Usually we'll refer to it as the PPF. That stands for Production Possibilities Frontier. You might, somewhere along the line, see it referred to as the PPC. That's for Production Possibilities Curve. That's essentially the same thing, but you can think of it just as the PPF. I only throw the other name in there just so that you're not thrown off if you ever hear it referred to that way. So, the Production Possibilities Frontier. This is a model, so it's built on some assumptions. I'm going to tell you the assumptions for this. There are three main ones. One, we live in a world with only two goods. One, resources are fixed, and technology is fixed, right? So there's no growth in technology. There's no introduction of new resources. So we live in a world with only two goods. Resources are fixed, and technology is fixed. Is this realistic? Yeah, we're probably going to say no, right? Clearly, we have way more than two goods in the world, right? We have the goods and services available for us to consume, number into the hundreds of thousands or millions, right, of things available. So it's totally not realistic. Does that mean that it's a horrible model or that it's not useful? Well, no, we tried to talk about this last week. The test of a model is its ability to predict. Does it do a good job of predicting how people will respond or what happens in the future? The test of a model is not whether it's based on realistic assumptions. So, but do be familiar with these building blocks of the model, these assumptions. So, here I said the graph. What we mean by that is what does the graph look like for a PPF? Well, we live in a world with only two goods, and that's convenient because when we draw things on a page, we have only two dimensions. So you can see the practicality, right, of having only two goods in the world. So imagine, and this is a production graph, so these are things you could produce. So imagine that you had a pizza shop, and you could make one of two things. You could make pizza, or you could make stromboli. I realize up here, Western New York, you're much more likely to find calzones. But since I'm not a huge fan of ricotta cheese, I like the stromboli. That's essentially the same stuff as the pizza wrapped up and baked. So imagine that you had a pizza shop, and what we're looking for is the graph of the possible combinations of the two goods that you can produce. So the PPF shows the maximum attainable combinations of two goods that you can produce. And so we can get there by thinking about the endpoints. So if you have a pizza shop, and now resources and technology are fixed. So in our example, you have a certain amount of resources, in your cooler and in your pantry area. You have a certain amount of time and workers. And so if you're open for, let's say, from, 11 a.m. until 10 p.m., so what is that, to 11 hours a day. And in a given day, if you had your workers fully employed, that is producing pizzas all day long, there's some maximum number of pizzas that they could make. And we would plot that on the vertical axis because I labeled the vertical axis pizza. So this represents some quantity of pizzas that you could make and 0 strombolis. I don't know what that number is. Maybe some of you have some pizza shop experience. It probably depends on the size of the shop. I don't know if a given shop could make 500 pizzas, in a day. So there's some number, though, that corresponds to that. But that's not the only possibility, right? You could also make strombolis. And what if you made only strombolis? And what if you, in a given day, you had all your workers cranking out strombolis? There's some maximum number of strombolis that they could make. Now, I don't know what it is. Is it the same as pizzas? Is it more? Is it less? I would imagine that strombolis have to bake a little bit longer in the oven, but you could also, they're smaller. Once they're wrapped up, you could get more of them in the oven at the same time. So if you made just strombolis all day long and had your people cranking out strombolis all day long, what's the maximum number you could make? I don't know. Maybe it's a little more than pizzas. Maybe it's a little less. I'm just going to call it 500 as well, but realize that there's nothing magical about it being exactly the same. It's just whatever, objectively, if you could measure it, what is the maximum number of strombolis you could crank out in a day? And of course, if you had a pizza shop, you don't have to make all of one and none of the other, right? There are combinations of the two goods that are in between. Maybe you could make 400 pizzas and 100 strombolis. Maybe you could make 250 pizzas and 250 strombolis, right? So there are other combinations. My dots did not quite line up there. Right, but there are other combinations of pizzas and strombolis that you could make, and when you put them all together, you get the production possibilities frontier. So the production possibilities frontier is the maximum attainable combinations of the two goods that you're talking about. So there's your first PPF. Now, we have a little more vocabulary to work on or areas to note here. Once you have your PPF, we can also identify some other things. Actually, let me stick with the white here for a second. I said that maybe I could make 250 pizzas and 250 strombolis. If I wanted to, could I make 250 pizzas and 3 strombolis? Could I produce here? Absolutely. Could I produce here or here or here or here? Or, if we wanted to sit around, could we just make, 5 strombolis and 3 pizzas in a day? Absolutely. Right. So I can produce, physically, I could produce anywhere on the PPF and inside of it. And so that's what we call the attainable range. So this is the vocabulary to go with it here. Attainable range is anything, we'll say everything on the PPF and within it. Right? All of that is attainable. Right? Everything on the PPF and inside of it. But then notice that if given my current technology and my current resources, could I make 500 pizzas and 300 strombolis? Could I produce here at the red dot? Or 500 of each? Or 270 of each? Or 500 pizzas and 2 strombolis. No, right? Anything outside of the PPF we call the unattainable range. Right? So that is everything outside the PPF. Anything outside of that is unattainable, at least given current resources and current technology. Now, we said for this model, we hold those constant. In the real world, do we ever discover new resources? Do we discover or invent new technologies? Absolutely. So in the real world, the PPF can move, right? It might shift over time. But for a given PPF, when you freeze that, when you hold technology and resources constant, then there's some maximum attainable combination of the two goods that you could produce. So we've talked about the attainable range and the unattainable range. We have one more distinction that we need to make, and that has to do within the attainable range, there are points on the curve, and that's where your workers and your supplies, you're busy all day long cranking out pizzas and strombolis. So points on the PPF are efficient points. And that means your resources are fully utilized. Right? Your workers are busy all day long. You're cooking all the pizzas and/or strombolis you can. So that if you are on the PPF, you're talking about efficient points. Right? So every dot that you could draw on this line represents an efficient point. Meanwhile, these other dots in here, right? I'll just put pink ones near them, right? So you can see all the pink and white dots inside. These are also combinations that you can produce. But if you have a whole, staff of people and you have your cooler stocked and you have your ovens cranking all day long, but at the end of the day you just make 3 or 4 pizzas and a handful of strombolis, that's attainable. You can do that, but have you fully utilized your resources? No. Right? And so these points in here we call inefficient points. And these are inside the PPF. So you have idle resources. Or you could say your resources are not fully employed throughout the day, right? You have workers just sitting around. You have the oven hot, but nothing in it sometimes. And so your resources are not fully employed, or you could say you have idle resources. So inefficient points would represent, they're attainable points, but inside of the PPF. So there you go. That's your basic setup and some of your basic vocabulary. Instinctively, I wanted to say, are there any questions? But given the format of this, it's probably better if you just make a note about your questions and follow up in an email or bring them to class on Wednesday. All right, so there's your basic setup. Now, this assumes that everything is, constant in terms of resources and technology, but it doesn't have to always stay, right? Sometimes those things change. So my next question are, and I my slides got a little gummed up when I went to PDF. I should have made another slide in here. But things that can shift the PPF. Things, there we go, plural. Things that can shift the PPF. There are 2 main ones, and then there's another one that I want to mention in passing. But they're the things that we held constant, right? So a change in resources could shift the PPF. If you find more resources, discover new resources or new ways to use them, that could allow you to produce more. And then also a change, I use delta, like the triangle for delta, and a change in technology. If you get new technology, that could allow you to produce more. Right? That could shift it out. So, over time, we see, for society, we tend to see the PPF shift outward. And that represents economic growth, right? Economic growth is the increase in the goods and services available for people in society. And the two of the big sources of that, 2 of the big things that cause the PPF to shift, are an increase in resources or an increase in technology. The other thing that I want to, I usually say change, a change in resources or a change in technology. We like to see it shift out. Sometimes there's a negative shock and it shifts in. The Black Plague, right, in Europe, that killed lots of people. People are also part of the workforce, right? And so if a huge part of your population dies, then your society's ability to make stuff decreases. If you have a hurricane that destroys oil refineries, and you'll see that they are not able to refine as much petroleum. So whether you were talking about gasoline or kerosene or diesel fuel, right, and heating oil, whatever the two refined petroleum products are you want to put on the axes, if your refineries are damaged by a hurricane, your capacity will go down, right? Your PPF will shift in. The other thing I want to mention here is a change in the rules of the game. We won't spend too much time on this, but institutions matter. If you live in a society that has good institutions, that are productive institutions, you will find that people can be more productive. So, for example, the rule of law or private property rights. Those would be examples of institutions that matter. So we may take this for granted in the U.S. because while it's certainly not perfect, not everyone is treated, equally under the law. Not things are not always perfectly adjudicated and enforced. But for the most part, we have a system of law that works, and we have a system of law that protects private property rights. So if somebody owns a productive resource, it belongs to them, and they can use it to produce things that make. So if I own a pizza shop, I can use it to make pizzas and strombolis, and I can sell them to other people. And if someone breaks in or someone destroys it, I can call the police. If someone shows up one day and just claims that it's theirs, I can sue them in court, right? We have mechanisms, we have institutions, and that's why I say the rule of law and private property rights are good examples of these that allow me to defend my claim to those resources. If I lawfully own something, then I have a means of protecting it. And it may be prudent for me to have good locks and to have an alarm system and to take reasonable precautions to secure it, but I don't have to take excessive precautions. I don't necessarily, it depends on the neighborhood perhaps, but generally speaking, I don't need lots and lots of bars on the windows or barbed wire or mean dogs or like security all night long, right? Just to secure my pizza shop in suburban Rochester. So, and because you understand that there's an opportunity cost, the more resources you have to spend just defending or protecting what is yours, the less you have available to produce, right? The more resources I spend on locks and security and night watchmen and mean dogs and bars in the windows, the less money I have to upgrade my pizza oven and buy more supplies and hire more workers and make more pizza. So less productive, less conducive institutions mean less productive possibilities, right? A PPF that's in farther. Good institution, good rules of the game allow people to be more productive. So that's just one example. And then for this I have, a narrative example, and then I'll show you a picture. One has to do with if you think about some less developed nations that do not have as good of institutions, if the government does not do a good job of defending private property rights and somebody bigger and stronger comes along and they can just take over your factory, they can take over your pizza shop, and there's little you can do to protect it, will you invest a lot of money into building a resource or a factory? Well, not if the government won't help you defend it. Right, help you protect that investment, you're less likely to make it. And so places with bad institutions or just institutions that don't protect private property rights and private investments may be less likely to attract those investments in the first place. So I show you this picture. Let's see if you can recognize what this is. This is a nighttime satellite photo, and then it has some borders superimposed. But if you haven't figured it out yet, this is North and South Korea, right? This is a satellite photo taken at night. And so, these are not really enormous countries. Are there massive differences in the resources available in terms of natural resources underground? Is one of them rich because they have oil and diamonds and the other one doesn't? Is one of them is the climate radically different? Can you attribute more economic growth on one to the really, really massive change in climate or weather or something else? No, it turns out that countries are not that big. They're very, very similar in terms of many natural resources and topography and weather. What's the big difference? Well, it has to do with the system of government. And this is anecdotal, right? This is just 2 data points. But it is interesting for countries that are very similar in many, many ways. The primary difference is the system of government. And you can see that South Korea has a lot of lights on at night and North Korea doesn't. So again, anecdotal, but something to think about, right? To support this thought about rules of the game. So one other thing to think about here, and I'm tired of this blue, I think it's a little harder to see. I said, does this always have to move outward? And the answer is no, right? It doesn't. If this is your PPF, so pick any 2 goods, A and B, will just be generic. It's not the case that it only moves out. If this is PPF 1 and PPF 2, right? This shift outward would represent economic growth. New resources, new technology, better rules of the game, or something else, cultural shifts, whatever it is, something that causes a nation, or a society to be more productive would look like an outward shift. But we said the Black Plague or something else could cause a shift in the other direction, right? You could start at PPF 1 and you could end up at PPF 0. Right? And that would be a leftward shift, some negative shock to the productive resources. The other thing to keep in mind is that think about when something is shifting, does it, how does it affect it? So let's look at another example. Here we'll put pies and down here we'll put cakes. And so if this is our initial PPF, right, and it's because it corresponds, you think about with the endpoints first, some maximum number of pies, some maximum number of cakes, and some other possible combinations. If that's PPF 1, then the other things to think about, what if I get new ovens, right? So what if in my bakery I buy new ovens? That's an increase in technology or an increase in resources. It doesn't matter. Maybe it's a higher tech oven, maybe it's just more ovens. It's not so much, I'm not as interested in you discerning, well, is that resources or is that technology? Well, it doesn't matter. You can sort of lump them together. New ovens represent an increase in resources and or technology that would allow you to make more pies and more cakes, right? So you could see your PPF shift out like this. Right? So more ovens would cause you to shift from PPF 1 to PPF 2. But what if now you said, all right, now I'm going to get this dough rolling machine that maybe I made pies by having my workers roll out the pie dough by hand. What if I get this machine where I can put in a big glob of dough mixture and it has some rollers and it presses a nice beautiful ribbon of pie dough that comes out the other end? Could that make me more productive? Well, yeah, if I only make pies, that might allow me to make a lot more pies than before. Let's extend my graph here. So I might make a lot more pies than before, right? So my maximum pie production would increase. Now, if I make only cakes, will my fancy dough rolling machine help me? Well, probably not, right? My maximum number of cakes wouldn't change. So my PPF shifts, well, I would call it rotates, right? It moves, but it rotates out where this endpoint stays the same. Cakes, if I made only cakes, that dough rolling machine wouldn't help me at all. But if I make only pies, it increases it a lot. So notice, other than this very, very end point, everywhere else along here, I can produce more pies and more cakes, but not because the dough rolling machine helps me make cakes. The dough rolling machine makes me much more productive at making pies, and that means that I have more time or resources to spend making cakes. So I could produce anywhere on this PPF. We'll label this PPF 3. But notice the difference between a shift where both endpoints move. Let's see if I can highlight this. Let's highlight it in orange. Notice the difference between a shift. You can't see that. All right, let's switch back. The difference between a shift where both endpoints move out and a rotation where one endpoint moves out and the other one stays still. So just be aware of that. If you know that your PPF is moving, think about, well, is it shifting out in both directions? Are both endpoints moving, or just the one? These are the intersections on the X and Y axis. Are they both moving or just one? Is it a rotation or a shift? All right, that is the basic model. That's where I want to start. I want to break these up so that the videos don't get too long, but there will be another short video about the shape of the PPF. That'll be coming up next. If you have questions, make a note of them, shoot me an email, come to office hours, or bring them to class. Otherwise, I'll talk to you all again.